We need to find out the value of the given trigonometric expression. So let us begin. First, what we'll do, we'll try to find out the values of each of the trigonometric ratio. So let us begin. So we'll start out with our first one. So here we have sine 180 degrees plus theta. So this is going to be also equivalent to sine. So we can rewrite 180 degrees as 2 times 90 degrees plus theta. The reason why I've written in this fashion, that's because now we have 90 degree multiplied to an even number. So we can say that's an even multiple of 90 degree. And whenever we have an even multiple of 90 degree, then our sine function is going to remain as the sine function. But the new angle is going to be theta instead of 180 plus theta. Now we are going to check the sine of this final value. So 2 times 90 means we are in the second quadrant. We start from the first quadrant, which is 1 times 90, and then we go in the anti-clockwise fashion. So 2 times 90 is going to take us to the second quadrant, but here we are adding theta to it. Theta is an acute angle between 0 and 90 degree. So that means we are now in the third quadrant. Now in the third quadrant, tangent and cotangent are positive. Everything else is negative. So this must give us a value negative sine theta. Similarly, we go to the next one. We have cosine of 90 degree plus theta. So this will be equals to cosine of 1 multiplied to 90 degree plus theta. This time we have an odd multiple of 90 degree. So whenever we have an odd multiple, then cosine will transform to sine. So we get sine theta, but 1 times 90 means we are in the first quadrant, and addition of theta takes us to the second quadrant. In the second quadrant, sine and cosine cosecant are positive, everything else is negative. So we must get a negative value. Do not get confused that we have a sine value while we're getting sine negative here. This negative sign is coming because of the fact that we are working with a cosine function here. So cosine in the second quadrant gives us a negative value. It's not what we are getting here, but it's the final result that should be negative. Fine. Next, we come to the tangent function. So we have tangent of 270 degree minus theta. This can be also expressed as tangent of 3 times 90 degree minus theta. Now theta 3 is an odd number, so odd multiple of 90 degree means tangent must transform, so give us cotangent function. So we'll get cotangent and the angle will be theta. So 3 times 90 means we are in the third quadrant and we're subtracting theta from it this time. But theta being an acute angle between 0 and 90, we are still going to lie in the third quadrant, and here we have tangent and cotangent both positive. So we are going to get a positive value. We started out with tangent function, so its value is going to be positive. Then coming to cotangent of 360 degree minus theta. So this is going to give us cotangent of 4 times 90. So that's 360 minus theta. So 4 is an even number. So here we have an even multiple of 90 degree. So cotangent will not change. We're going to get simply cotangent and the angle will be theta. So 4 times 90 means we are in the fourth quadrant and we're subtracting theta from it. So that's fine. We're still going to lie in the fourth quadrant because theta is between 0 and 90 degree. So in this quadrant, only cosine and secant are positive. Everything else is negative. So this is going to give us a negative value. So using the same technique, we can find out the values of each of the ratios in the denominator. So let me note them down. You can try it out. The sine of 360 degree minus theta, that's going to be equals to sine theta. Here we'll be in the fourth quadrant where only the cosine function is positive. So we're going to get negative sine theta. Cosine of 360 plus theta is going to give us cosine theta, but 360 plus theta is going to take us to the first quadrant where everything is positive. Cosecant function is an odd function, so we're going to get negative cosecant of theta. And sine 270 plus theta is going to give us cosine theta. 270 plus theta means we are in the fourth quadrant where only the cosine and secant are positive, but we're working with the sine function, so we're going to get negative cosine theta. So we can replace all these trigonometric ratios with their simplified values, and this is going to give us, so we have sine 180 degree plus theta, that's going to be negative sine theta. All multiplied to cosine of 90 degree plus theta, so that's negative sine theta. Tangent of 270 minus theta, so we have cotangent of theta. Then cotangent of 360 degree minus theta, so that's negative cotangent of theta. All divided by, we have sine 360 degree minus theta, that came out as negative sine theta. Then we have cosine of 360 plus theta, so that's cosine of theta. multiplied to cosecant of negative theta, so that's negative cosecant of theta, times, and sine 270 plus theta is negative cosine theta. Now we can factor out negative sine theta from the numerator and the denominator. And now we are left with, so negative times negative will be positive. So positive sine theta times cotangent squared theta in the numerator, whole divided by, we have negative and negative will be positive. We have cosecant theta multiplied to cosine theta times cosine theta, so that's cosine squared theta. Now we know that cosecant function, that is the reciprocal of the sine function, so this will get go to the numerator and combine with sine theta to give us sine squared theta. So sine squared theta divided by cosine squared theta will multiply to cotangent squared theta. Now the ratio sine over cosine, that is a tangent function. So we have tangent squared theta multiplied to cotangent squared theta. Also, tangent theta is the reciprocal of the cotangent function, so the product must be equals to 1. So this is going to be the final value of our given trigonometric expression. So this is going to be equals to 1.